this question then. This seems to be something I've seen crop up quite a bit of time over the last few years. If you know what you're doing, it's a pretty standard question. The problem I found with this one when I've looked at it is, where does it fit in the spec? If you look, so the actual topic this comes under is straight line graphs, which is a first year topic, and it's at the end of that topic, it's linear modelling. But whenever I've looked at the examples and the things in the textbooks, this just isn't there. But then I've seen several exam questions that are like this, so I'm just going to show you how I would do this one. So the main thing you're looking for this question, quite handily with this one, they have actually put your main detail in bold in this question. You can see it in the fourth paragraph. Linear model is the thing you're looking for, and that's how we know what we're supposed to do in this case, and that will always be there. It might not always be bold. So because it's a linear model, and I can write it as a straight line graph. Okay. That would be my normal y equals mx plus c. In this case, I've not got y, I've got v and d. I've not got y and x. Now, the trick sometimes can be put in the way that you put the letters round, but we're looking at how much litres of fuel, in terms of the volume of it, is remaining after so many miles. So how much fuel, what's the volume of fuel after so many miles, or the distance in miles. And we can still, now you can leave those letters as M and C if you want. You can write A and B, it doesn't really matter. As long as you've got V and D as the correct letters, these two, I can do them as M and C, I could do whatever. And then we need to use the information we've been given. So if the fuel, from full tank of fuel, is 40 litres remaining after it's travelled 80 kilometres. So 40, it's travelled 80 M plus C, and also there's 25, I've travelled 200. And as you can see there, we've got a pair of simultaneous equations with an M and a C in. And quite handy with these questions, you see your y-intercept, if you subtract one from the other, it's going to cancel. Okay, so let's have a look, let's see which way around I'm going to decide to do this. And you might look and think, why is it decreasing? Well, it's going to decrease. The amount of, or the volume of the fuel is going to be less the further you drive. So that makes sense. So call that equation 1, that equation 2. I'm going to subtract 2 from 1. That's going to give me 40 minus 25 is 15, 80 minus 200 is minus 120, and the C's cancel. Divide there, and that's going to give me minus an eighth if I leave that as a fraction. Alright, and then I can substitute that back into either of those and find what C is. It seems fairly straightforward that I might as well stick it back into that one, because minus an eighth of 80 is going to give me minus 10 on my y-intercept equals 50, and we want the equation linking V and D, so the full equation will now be it's an eighth D plus 50, and that's going to tell us quite a lot of information. So that's part A done. So yeah, generally standard, they give you 2 sets of information, therefore you're going to be able to use a pair of simultaneous equations, and you'll be able to subtract one from the other. So cancel the y-intercept off and find the gradient first, substitute it back in, and you'll have your y-intercept then. Let's have a look at part B then. So given on a particular journey, the car was initially full, and it continued until it ran out of fuel. Okay, so if the car was initially full, that means the y-intercept is how much the car can hold, and also it's the initial volume as well. So I mean, you could make D0, but we can see it's 50. That's assuming in litres. Yeah, it's in litres. All right. And then the distance that it travelled. That's going to be when that V is empty. Have a look. Going to make the volume equal to 0. At that 8D, and then we'll times both sides by 8. That's going to give me 400 kilometres. kilometres. So just a bit of basic information there. So for BI, what I've done is, I just need to read the y-intercept. BII, I need to make the volume equal to 0, so when it's empty, like this, times by 8. Okay, and then it's quite a common part for these kind of questions. Evaluate the model in light of that information. Well, if the car has actually travelled 320 kilometres, that's quite a big difference. Significant, I could say that's significantly less than 400. So it's not a good model. So what you're looking for is you're comparing the numbers. If they're close, then it is a good model. If they're not, then it's not a good model. Significantly less.